Question 9, last question in the paper. Hooray! Okay, so it's questions about a plane. It tells you what the mass of the plane is, and it gives you the thrust force of the engines. Okay, so that thrust force is going to be the force forward for the engines. So there we go. I've marked on the 8,000 newtons thrust from the engine, and I've also marked on the 340 newtons resistive forces between the wheels and the ground. So now that we've got those two forces, we can work out the total force, which of course is sigma F. So there we go, there's the total force, 7,660 newtons to the left. But we know a formula that's got resultant force in it. Okay, and that is sigma F equals ma. So now we know the sigma F, and we also know the mass of the plane. Then it's pretty straightforward for us to calculate A, which comes out at 2.99. Don't forget the units, meters per second squared. So why is the acceleration going to get smaller as the plane speeds up? Well, as the plane speeds up, the speed of the plane is going to increase, which means, well, you can try this experiment for yourself. Put your hand out in front of you. Can you feel the air resistance? Nope, because it's not moving. Now move your hand slightly left to right. Can you feel the air pushing back on your hand? Slightly. Now move your hand left to right as fast as you can. Can you feel the air pushing back on it? Yes. A lot. So as the speed increases, so does the air resistance. Now that, amazingly, is enough to get you 2 marks. Okay. Personally, I'd have expected a little bit more explanation. The idea that as the air resistance increases, the resistive force is now going to be bigger than 340 newtons, which means this number here is going to get smaller. And if this number here gets smaller, and this number here stays the same, the only way for that to happen is if the acceleration also gets smaller. Okay, but yeah, for 2 marks, all that they really wanted was what's on the screen. Okay, in the question they've given us the acceleration and they've given us the takeoff speed, and they're asking us for the time. So hopefully you can see that this is the equation that we need, a equals v minus u over t. And then it's up to you whether you want to rearrange and then substitute, or substitute then rearrange. My personal preference is to substitute then rearrange, but it's really up to you. Okay, so the takeoff speed is 55 meters per second. The initial speed is going to be 0 because it wasn't moving at the beginning. Okay, and then you can rearrange that so that you get 55 divided by 2.2, which should get you a time of 25 seconds if you work it out on the calculator.